In this demonstration, we're going to show you the effect that surface area has on the rate of the combustion of methanol. Here's the setup. A small amount of methanol is poured into a blue plastic bottle. Now, methanol is flammable. All alcohols are to one extent or another. If you have a lot of methanol, it burns with a nice, gentle blue flame. However, we're going to make it burn a little faster. How are we going to do that? We're going to do that by increasing the surface area of the reaction. Notice how small the opening of the bottle is compared to its volume. That tends to concentrate the vapors that are coming off of the liquid inside. Also notice that the experimenter jiggles the bottle around. That tends to increase the amount of evaporation going on. So in the end, we've got a lot of vapor inside this bottle. Now in a moment, the experimenter is going to ignite the methanol vapor inside the bottle. If you ignite methanol liquid, you just get a nice, gentle blue flame. It's actually kind of pleasant. However, if you ignite the vapor, something quite different happens. Watch this. You saw a blue flame, didn't you? But it wasn't a gentle blue flame, was it? It erupted out of that bottle. Why did that happen? Well, I'm going to explain it to you while the experimenter sets up to do this one more time. All right. Now remember what we've got in this bottle. We've got methanol vapor, not methanol liquid. Now, when you first think about this, you might think that the combustion of methanol vapor is actually slower than the combustion of methanol liquid. After all, liquid is more concentrated than vapor, and the rate of a chemical reaction depends on the concentration of the reactants. So therefore, you would expect maybe that methanol vapor would burn more slowly because it is less concentrated. But that kind of reasoning neglects that there's a second reactant here, oxygen. For the combustion of anything, we need the substance and oxygen. So there's oxygen in this mix too. Now, in order for these reactants to get together and cause a reaction, they have to mingle with one another. If I'm burning liquid, the only place the oxygen can mingle with the liquid is on the surface. So you get a small surface area for the reaction. If I allow that liquid to vaporize, however, the vapors mingle with oxygen a lot more, so you get a much larger surface area over which the reaction can occur. That increases the rate dramatically. Have you ever heard that gasoline vapor is more explosive than gasoline liquid? It's the same principle. Because the vapor presents a larger surface area, the rate of the reaction is much larger.